Okay, so this is a video to go over the key problems that people found with the Educake test in 9.3a. So could you make sure, 9.3b. So could you make sure, if you haven't yet done the Educake test, that you leave this video, go back to the previous assignment, and get on with doing that test, and then return here after you've done it. Okay, so the first issue, people seem to struggle with this question. So what word completes the gap? The something of a gas is due to the force exerted on the walls of the container by the gas particles colliding with it. So the answer to this one was pressure. And what I'd like you to do in this video is to have some paper and to jot down the key points about these questions that I've included in the going deeper section. So the first thing I'd like you to write down is that pressure is equal to force divided by area. And when force is in newtons and area is measured in meters squared, the pressure is, one way you can say it is in a unit called pascals, and that's capital P and little a. So let's just go to this animation here. So we have some particles of a gas trapped in a box. How do I know they're a gas? Well, the particles are traveling around individually at a range of speeds and in random directions. So we have a pressure gauge, which is this dial to the right of the box, and the slider allows me to change the temperature and then investigate what's happening to the pressure. So just before we begin, in your own heads, I'm about to make the box hotter. Could you predict in your heads what happens to the pressure? So let's give it a go. Let's make it really hot. And you can see that the pressure gauge went up. So why is it then that higher temperature objects exert greater pressures on the walls of their container? The area of the walls haven't changed. We've got 4 walls here, and they were the same in either case. So we can go back to the middle. The walls are the same. So it's got to do with the other thing in the equation, which is the force. So we always talk about how heating up a box with particles in, or something, a substance with particles in, we always talk about the effect that has on pressure going through a number of steps, and those steps are always the same. So the first thing is, if you heat up something, its temperature increases if it's not changing state. So here, we're already a gas, and there is actually a state of matter which can be achieved if you do heat up a gas to incredibly high temperatures, but that's not discussed at GCSE or A level. So it's not going to change state, but we are going to have an increase in temperature. This one leads to, I should have had another arrow there. This leads to the average kinetic energy of the particles increasing, which basically means that the particles are doing 2 things. If they're moving around quicker because they've got more kinetic energy on average, they are going to bump into the walls, and the area of the 4 walls haven't changed, but they're going to bump into the walls more frequently, and each time they collide with the walls, they are going to exert, each colliding particle is going to exert a greater force than it would have done had that particle be going a lot slower. So there's 2 things that you need to kind of know. More kinetic energy leads to faster moving particles on average, and that means they collide more frequently with the walls, and there is a greater force per collision on average. And these two things lead to another thing, which is that these two things lead to an increase in the force on the walls. And if the force goes up, it's in the numerator of this equation, that must mean the pressure goes up. So that brings the last point, an increase in pressure. So please make a note of that flow chart, because these steps are really useful for talking through why an increase in temperature of a gas often means it exerts a greater pressure on its walls. And this question comes up, slightly differently, but they expect the same stages in the responses. You to talk through each step of this flow chart there. Next question. So people struggle with this one. So an ice cube is melting but does not change in temperature. Complete the gap to state the name given to the energy that is needed to melt the ice cube. Latent blank. And they've given you a hint. Your answer should be 3 words. So the answer to this one, the full thing that's happening here is the energy needed to change a solid into a liquid is called the heat of fusion, latent heat of fusion. So if you add the answer to the word latent that was there already, we've got the phrase latent heat of fusion. So there's a number of things which I'd like you to note down and make sure that you learn. The first thing is, when a substance is being heated but its temperature isn't going up, that usually means in our physics matter topic that the substance is changing state. There are 2 ways to label state changes that you need to know about. If it's going from a solid to a liquid or vice versa, that is called fusion. And if it's going from a liquid to a gas, or the other way around, a gas to a liquid, that is called vaporization. And let's see if I can spell that correctly. Vaporization. Okay, so autocorrect kicked in there. Apologies for that. Now, if we're talking about the amount of energy a substance needs to go from a solid to a liquid, or that you get from allowing it to return to being a solid after starting at a liquid, is called the latent heat of fusion, which is this point here. The energy needed to go from a liquid to a gas is called the latent heat of vaporization. And the word latent really means hidden. And it's hidden because there's no change of temperature when you're heating these things to make the state change happen. State changes happen at constant temperature. So fusion means solid to a liquid or vice versa. Vaporization means liquid to a gas or vice versa. Now, we add the word specific to that usually in this course. And the word specific refers to 1 kilogram of substance. So I really do recommend that you note down this definition that I'm highlighting, the specific latent heat of fusion, and this definition, the specific latent heat of vaporization. So the specific latent heat of fusion, the energy needed to change 1 kilogram of substance from a solid to a liquid. And specific latent heat, the energy needed to change 1 kilogram of substance from a liquid to a gas. So there's lots of key points that you really do need to learn so you can practice using. Okay, so they've come up twice in this course now. Once when I made a video about 6 weeks ago, one of my first videos for the YouTube channel, and yet again on this one. So if you don't learn them, you will not be able to apply them to situations that they give you. Alright, so you must make an effort to write these down and learn them. So press pause on the video and make sure you write them down, highlight them, put stars next to them. They are really important. Okay, next one. Internal energy is the energy stored inside a system by the blank that make up the system. So the accepted answers you could get were particles, atoms, or molecules. So some stuff to make sure that you learn. So it's a fairly broad label, internal energy, but this is the definition to learn. The internal energy is the sum of kinetic and potential energies. Let's correct that spelling for you. Of all particles. So every particle has a store of kinetic energy. It's moving around quickly or slowly, or actually you might consider if a particle's not moving around in a substance, and actually in terms of the laws of what we say thermodynamics, you never ever get a truly stationary particle on a particle level. So that must mean there's always a store of kinetic energy that a particle has. Particles also have a store of potential energy. If they're separated a lot more from other particles, they have a higher store of potential energy. And if they're not separated as much, they have a lower store of potential energy. So if we ask every particle in a substance two questions. The first one, how much kinetic energy do you have in your store? And the second one, how much potential energy do you have in your store? And we ask every particle that same question, and then we add up all the energies they give us. That would be the internal energy of your substance. So something like ice, the particles are in solid formation, which means that they're not moving around that much, and the separation is very low. So that would lead to a lower internal energy. If we compare that to something like the gas of hydrogen in the sun, which is the main gas that makes up our sun, the temperatures are very high, so the kinetic energy store of each particle, and consequently all the particles, is going to be really high. And because gases have greater particle separations, they're going to have a greater potential energy store. So the hydrogen that makes up our sun is going to have a huge internal energy store. So please pause this and make sure that you copy down the rules of thumb. All right. Again, they're really, really important to know. The basics. If an object is increasing in temperature, its kinetic energy store is increasing. The particles are moving around faster on average. Number two, if a substance is changing state, then the temperature is not changing. This means that the kinetic energy store is not changing, but the potential energy store is. The energy is being used to break bonds between particles and increase their separation. So, changing state breaks bonds between solids, so they can form into, they can change state into a liquid, or breaks bonds between particles in a liquid so that they can change state into a gas. And in each of those instances, the average particle separation is increasing, so the potential energy store of those of the particles in the substance is increasing. So I hope you can kind of realize that it is fairly wordy, but once you kind of learn the rules and you learn how to say and express what's going on, then you can really answer any questions. Next one. The heat of an object is a measure of the amount of energy in its something energy store. What is the missing word in this sentence? The answer is thermal. So some points to remember here. So higher temperature objects store more thermal energy because, firstly, their particles are moving around faster on average. So they have a higher amount of kinetic energy in their store. Secondly, the particles have a higher average separation, which increases their store of potential energy. So in a gas, the particles are more separate, and that means that they've got a higher store of potential energy. So again, we can see that out of most questions, the underlying understanding is just a few key core points that you need to have learned. Okay, so take a picture of your notes, upload it to show my homework, and well done, and keep going. All right, you're doing extremely well. I know it's difficult, this remote learning stuff, but well done to all the people who are regularly following instructions and doing their best. Okay, goodbye.